name is Lars, and I'm going to talk about Scala set 7 and new and polished features in that version. And the title of the talk is 7 at one blow. That's actually a proverb from a German fairy tale. It's called The Valiant Little Tailor, and I have no clue what's that got to do with the topic, but it has a 7 in it, so yeah. Okay, so some people might already know me. So my name is Lars, and I'm studying computer science. And my first contribution to Scala set was in December 2011. And I've became committer shortly afterwards. And in October, I picked up like co-maintenance or maintenance of this stuff. And just a side note, so I did not actually invent any of this stuff I'm going to present today. So most of it was already there. And some of it is coming from Miles and some other from Jason and Paul. And yeah, so I did not invent any of this, so please don't credit myself for that. Okay, so who of you uses Scala set in production or for hobby projects? So, okay, who uses Specs 2 for testing? So you also actually use Scala set because Specs 2 depends on Scala set. So Scala set is a Scala library for functional programming, and it contains purely functional data structures. And also it mirrors the type classes which came from Haskell originally, so like functors and monoids and monads and all that stuff. And the current stable version is 6.04, and yeah, the successor has been under development for over a year now. So it's compatible with Scala 2.9 and 2.10, so if you're still stuck with 2.8 or even 2.7, you're out of luck, you have to use something older. But if you're starting a project now, I'm going to argue that you should be using Scala set 7, and it should work out all pretty well. So here's my agenda for today. I'm probably not going to cover everything in 30 minutes, so let's just see how everything works out. First of all, à-la-carte implicits. So if you're used to Scala set 6, you know that if you want to use any of the functionality, you had this so-called all-you-can-eat object, and you import it from that object, so you make a wildcard import, and you got all the features. You got most of the implicits and stuff like that. So here's an example. So first you import the namespace, then you import this all-you-can-eat object, and then you can obtain all instances, so monad for option, and you also get this applicative builder syntax. And yeah, everything's just there at your fingertips. Now, in Scala set 7, there's, it's a bit more complicated. We distinguish between different kinds of implicits. First of all, we have type class instances, like this thing here. This is a type class instance. And there's also another separation, so we distinguish between type class instances of our own data types and of instances of standard library types. And the second part is infix operators. That's what we call syntax now. So this is all this fancy stuff here. That's syntax, because that's not usually there, and this fancy monoid addition operator. Yeah, and there's also there are infix operators for type class instances, and also additional syntax for standard library types, like you've seen here for integer we provide some separate syntax. And also the third kind, it's not really implicits, like the functions on our data types, that are just bare functions to construct our own data types, and yeah, this is also a third category. So what do you have to do now in order to import that stuff? So first of all, you use the namespace as you did previously, and then you can say, okay, I want the instances for option. So we have the sub-package called std, and in this sub-package there's an object called option, and in this object all the implicits reside. So if you import this, you get the monad instance for option. And as you might have noticed, you don't have to write implicitly here, so all our type classes now have companion objects with an apply method, and so you don't have to actually write this implicitly. And you just call the apply method and get your instance. Okay, now to the second example, and now we need a bit more imports. And that's actually a quite nice example, because now we can actually see that this line of code contains so much of stuff from Scala set. So let's break it down. The first thing to notice is, let's start with the syntax. Okay, we have this applicative builder syntax here, so we have this fancy operator, and it's defined not an applicative, but an apply, but that's just a technical distinction. So you have to import the syntax for this type class. Then you use this addition operator, so you have to import the syntax.semigroup. Also, you use this syntax on standard library data types, and you have to import that too. So it lives under syntax.std.option. So this is the syntax to create options. So that's the first step. Now you have all the necessary syntax, and now the syntax has to know that it's actually that all the type class instances are there. So now you have to import the type class instances. You do that with importing stuff from option and stuff from anyvel, because here you need the applicative instance for option, and here you need the monoid instance for integer, and those live in anyvel. Okay, now you might argue that these are quite a lot of imports, and that's not really nice. So we also provided some common imports which provide you with all the syntax and all our library enrichments. So that makes it a bit shorter. Okay, why is this better? Let's start with the disadvantages. So obviously you need more import statements. Yeah, that's true. And also it makes compile time debugging harder. Why? Because if you're referring to a syntax, so if you write like X and then this operator and then Y, and the compiler complains that it couldn't find any implicit instance. So now you have to think, did I actually import everything which is needed, or is the instance just not there, or what happened here? So it takes you a bit of time to debug this kind of stuff. So, but there are also advantages. So you can use the syntax, but you don't have to. So if you decide to just use the type class instances and write everything with type class dot append or add and then 2 parameters, and if you choose to not use the syntax, that's fine. You can just import the type class instances and everything works well. And also it improves readability of the code. So if you have your source file and in the header you list all the imports, and someone reads your code, he or she could simply look, did this person import Scala set syntax? If yes, I have to watch out. There might be operators around here which I have to look up. And if you don't import syntax, you immediately know, okay, everything's from the standard library here. Also, it makes compile time debugging easier, so this is with tongue-in-cheek, because your implicit scope is much smaller. You don't have all those hundreds of thousands of implicits in your scope, so if you get a divergent implicit or stuff like that, you can just remove import statements one by one and see which one was the offender. So you couldn't do that with this all-you-can-eat object. You just had to import it, and if something didn't work, yeah, well, you were out of luck. Also, it increases compilation speed. I don't have any hard numbers on that, but the thing is, the implicit scope is smaller, so the implicit search will be faster. Okay. So, the second thing which improves the usability of Scala set by far is so-called unapply. So, who of you have heard of that? So, I'm not talking about the case class unapply, but about type level unapply. So, just for me, how many people do you know this concept? Okay, so this concept was originally invented by Miles and then refined by Jason. So, what's the problem? Just take a second to have a look at that code snippet. We define a function with 2 type parameters, where the first type parameter is actually a type constructor. And then we want to take a value x, which is of type constructor applied to A, and we just, for the sake of example, we just return x itself. So what we require is that if we want to call f, we need to know that it has a type such that it can be destructured into this type constructor and an element applied to it. Yeah, like list of int or vector of string or something like that. So what happens if you call it like that? Anybody know what happens? Does it compile? Does it not compile? Well, this actually prints a type error. Because we put in a function from int to int in here, but we required this type constructor thingy. And the compiler is not able to figure this out. So now you could say, okay, well, why doesn't the compiler figure this out? Isn't it smart enough? The reason is it's very hard to do so. And why is that? Because now assume you were the compiler, and I'd ask you to do this kind of inference. Which one of those candidates would you choose? Well, this type constructor could be fixed on the input. It could also be fixed on the result. It couldn't be fixed at all, or it could be fixed on both of them. So you don't actually know which destructuring you should choose because it's ambiguous. And this is a known limitation. This is also filed as a bug, and this is a bug number less than 3,000, so it's a feature request, and I'm not sure if this is ever going to happen. So let's go to so in the last year I would have probably said let's go to the fundament of the problem, but then someone said to me that fundament doesn't mean what I think it means, so let's go to the foundation of the problem, and we use math for that. This problem is known as higher order unification. So if someone of you have already used Prolog or Datalog, Prolog does unification. So it takes two terms and tries to find a mapping between them such that they look the same thing. So that's what we do here. So we try to find a mapping from this thing to this thing so that these constraints are satisfied. That's basically unification. And now Scala adds subtyping. So why is this bad? Because everything is subtype of any. Any is always treated as well-kinded, and that's instantly ambiguous. So no matter how hard you try, any is always a candidate. So you get ambiguities all the way down. And even without subtyping, higher order unification is undecidable. Even second order unification is undecidable. So yeah, that's pretty sad. Yeah, so in fact, Scala C is not stupid, or the implementation, or the people who implemented it were not lazy. It's just impossible to do in a general case. So, as good programmers, what do? We approximate. So that's what we do all day. So we have some hard problems and we can't solve it directly, so we have to use some kind of approximation to get rid of those limitations and like find a solution which just works and is close enough. So first thing to notice. This is the same code example, and we note that this type constructor here is rarely useful. It's not actually useful, so you cannot actually do something with the structure. You require that this type here is structured in a certain way, but you cannot actually do anything with it. You cannot transform it in some way. So the important thing to note is if you have a type constructor, you usually have also a type class. So you want this to be a functor or a monad or something like that. So this is a more realistic example. You have a function again with this type constructor, and you say, okay, I want my type constructor to be a monad. And then I can do some operations. I can map a type or whatever I want. And now we have more information, and this piece of information can guide type inference. How? Yeah, we can use dependent types for that. What we do is we define a proof object which contains the type constructor, the inner type, and the type class instance. And now we have to create that kind of proof object somehow, and we do that with implicits and lots of implicits. And now we have to resolve those ambiguities, and we do that by the usual mechanism of prioritization. So, you know, if you have a hierarchy of classes or traits or whatever, and you define implicits in all those traits. And now you ask for an implicit value, and multiple of those implicits would qualify. Then the compiler always chooses the one which is at the bottom of this hierarchy. So that's one mechanism. So we simply say, if there are two possibilities, just choose the one we deem more likely. And also availability of type class instances. So if you have two possibilities, and you say, well, you could destructure it in two ways, but in only one way I have this monad instance available, then I'll choose just that one which has the monad instance available, because the other destructuring wouldn't make any sense at all. Okay, here's a short demo. Oops. So, okay. So let's first have a look at how it's implemented. So this is quite a lot of boilerplate. So you don't have to actually understand that. These are like 500 lines of boilerplate which cover some type shapes. So the most important thing is the definition of this proof object, which is here. So here's the straight unapply. And you see here you have all those different members, like the type constructor and the type A and the type class instance. And we can use that. We can just ask for this proof object and the implicit search will give it to us. And this looks like the following. Assume we have this file, and now we want to have this class which does something on something else, and we want to create such an instance. We simply say, okay, just give me anything. I don't care what type that is, just something. And then I require such a proof object and say, okay, this T can be destructured in a way that we have a type constructor, and this type constructor is classified by a functor. So we need a functor for that type class. And then here where the dependent types come into play, we can say, okay, we instantiate our replicate class with this unapply.m, unapply.a. So these are the type parameters. And then just some technical details we have to convert a bit, and then here we get the type class instance. Okay, and that works pretty well. So if you have this code, you can actually call that and it will compile without a problem. So now that invokes Scala Zero, so let's hope this won't take too long. Yeah, so it compiles without a problem. It was able to infer that the shape of the type constructor, despite the fact that we passed in a function which is like function 1 and has 2 parameters, and it was able to unapply in such a way that everything works out beautifully. So, does it work? Well, yes. In Scala set 6, we used to have conversions for each concrete type. So we had conversions for either, for function 1, function 2, and all that stuff. And now we have a general mechanism for common shapes. So we say, okay, we have a conversion for type constructors which take 2 parameters, and then we have conversions for type constructor which take 3 parameters and stuff like that. So in many cases, type parameters can be omitted. And here's the thing. So if you want to traverse a list statefully, so I don't know who of you uses the state thingy from Scala set. Previously in Scala set 6, you had to use a very hideous type lambda here to actually tell the compiler how this should work out. And now we have this traverse U method. U stands for unapply, and the compiler will figure it out. And we also have the old traverse method still lying around, because in some cases unapply won't work, so you can still specify it like you used to do it. So, but it's not so bright because we have those amount of boilerplate, and we need one implicit per type shape, but there are infinitely many type shapes, so we are doomed anyway. But I don't know if any one of you uses type constructors with 20 parameters, so if you do, you might be doing something wrong. I'd say there's only a finite number of interesting type constructors, so yeah, we are not doomed at all. Also, the compile errors can get a little funky, and yeah, it needs dependent types. So with Scala 2.9, you have to specify a command line switch -y dependent method types or something like that. But this is enabled by default in Scala 2.10, so you can enable it anyway. You won't get any compatibility problems at all. It's enabled with 2.10, and yeah, you should be safe to use that. Okay, so let's get to the third point, laws. In Scala set 6, we had all those type classes and instances, and the problem was that you could implement your own instances and nobody actually ever checked whether your instances are lawful. So you could just define a functor and nobody ever checked if this was a valid functor. We did change that. So, first bit of motivation. So we are programmers, so we usually don't program against classes, we program against interfaces. And in Java land, we used to specify a contract in the Java doc comment. So this is object.equals. I am sure every one of you loves that method. And we have this kind of contract here, and it says, well, the equals method and blurb, and it should be reflexive, so x should always be equal to x, and if x is equal to y, then y should be equal to x. And yeah, we do rely on that on a daily basis. So if we implement some sort of sets or stuff like that, we do want these, we do want subclasses of object to satisfy that contract. And I assume everybody of you is completely convinced that every subclass of object adheres to this contract. So we have the same problem with type classes. So type classes abstract over types, and they offer common functionality. And users of those type classes expect similar behavior. And once again, we do not program against the list functor, we program against the functor. And we have a method, and we do not know which kind of functor the user puts into it. So we need to have some hard and fast rules for that. And those rules need to be formalized. So yeah, I'm an academic, I want to formalize everything. Why? Because if you put it just in your comments, nobody can check it and everybody will ignore it. And also, comments will rot. So you have like your implementation, and then like 2 years ago, somebody wrote a comment and the implementation doesn't even know about the old comment anymore. So yeah, we need to do something about that. And this is a quote from Tony Morris in the Scala set IRC channel. I think this was from a Twitter project, and he was wondering whether this is actually a lawful monoid, so whether it satisfies some laws. And we do not want to run into some legal problems. Okay, so how do we do it in Scala set? We have this type class hierarchy, and in this type classes, we embed laws. So for example, the class monad contains a trait called monad law, and this trait monad law extends functor law, and functor law itself is defined in functor. Yep. Nothing too specific. And then we have one method per law, and we call those methods with Scala check. So is everybody of you familiar with Scala check? So this is just a tool which produces random input, but here's the thing, it's not a theorem prover. So in an ideal world, we would just define our instances in a theorem prover and then click on a button, export to Scala, and then we have trustful code. We do not usually do that. So if Scala check says okay, it's not a guarantee, but it's better than the usual unit tests, because in usual unit tests you just test some cases which you thought would be common or whatever, and Scala check is good at creating corner cases, and usually the corner cases are more interesting. And our bindings to Scala check can be used by other projects, so if you are defining instances of functor or stuff like that, you can just add another dependency. It's called Scala set Scala check binding, and then you can simply call all those functions. And we call this check all, so if you call check all with an instance, it will automatically check everything. And in our own code base, we have 332 occurrences, so we take this pretty seriously. And yeah, the test suite of Scala set 7 is much better than of Scala set 6, so we didn't do that checking previously, but now we do, and now we are pretty confident that everything is in order. Okay, I have another demo. So let me just show you how that looks like. For example, for our annual instances, we just say check all the laws for the unit instance, and check all the laws for the Boolean and character and stuff like that. Here's also no benchmarking stuff, but that's not important. And this file just contains all those check all calls. And if you were about to execute that, so this is called SPT. I hope it doesn't recompile everything. So yeah, that worked out well. Internally, it uses specs2, and it generates specs2 fragments from those Scala check properties. And now you can see, if you want to check this short instance, you see all those laws which it checked for that. So that's pretty awesome. You just have to call check all, and everything will be done for you. Okay, so if you want to know more about laws, you can watch a talk by Nick Partridge. He gave it in the past week at the Brisbane FP group, and there are also slides available. Okay, since I think I'm running out of time, so I'm just going to skip type-level programming, and if you want to know more about type-level programming, ask Miles. And I'm going to skip to the last point, when I want to point something out about our community. So what actually happened in the past year? I've told you that Scala set 7 has been under development for quite some time, and the wiki says it should be released, expect and release in April 2012. Well, we are well overdue, and but we got tons of contributions, so about 200 issues opened and pull requests. We got quite a number of awesome contributions. For example, we got new data types and some classes which do not have any laws associated removed, and I'm still on a quest to remove more lawless classes, and lenses which have been some new concepts which have been ported from the Haskell lens library and stuff like that. That's pretty cool, and I'm going to plug, give a shameless plug here. This is something I've been doing. So some people say validation is the gateway drug to Scala set, and I thought to myself, so if it's a gateway drug, let's make it even cheaper. And the problem with using validation is that sometimes in code you have all those fancy operators and nobody knows how to call them or whatever, like spaceship operators or stuff like that. And yeah. So what I did is create such a DSL, such you can say, okay, I create such a checking object and I put some value in it, and then I can say, okay, verify all those properties, and there's a library which, with some of those properties readily available, and it will track all failures and give you a list of all the failures combined, and then you can also convert that stuff, and at the end you can get a full-fledged Scala set validation out of it, and if you would run that, you would see, okay, this thing has actually only 15 characters, so you get a wrong length, and it also doesn't satisfy this checksum function, so you also get this error. And yeah, I hope that's useful. And this is not actually in Scala set 6, in the Scala set code base. It's in a separate project, so this this enables us to move forward quickly. So, what can you do? If you're using Scala set 6, please migrate to the latest milestone, which is 700M7, and please tell us about it. So there are some things which you have to adapt for Scala set 7. So there will be a bit of pain, but please tell us about your pain so we can ease it for the next people to do that transition. If you're not using Scala set 7 or Scala set 6 at all, please try to adopt it in your project. So if you're starting a new project, just put it in your build SPT and see what happens. And also, please don't be afraid of asking questions. I know that the Scala set community is kind of infamous for, like, yeah, some people. And please ask questions on the mailing list, and yeah, I'm sure somebody will give you a helpful answer. So what are we going to do? We will release the final version soon, probably still this year. And we also promise to not break too much until then. And also on the point on my agenda is to revamp the website, so we have still this Google Code wiki and stuff like that. And I hope to replace that by something more beautiful. Okay, that's it from me.